Welcoming everyone back to the Enginears Podcast. Thanks for joining us. Today we have Andre, who's the Director of Engineering at Pegasystems over in Netherlands. Pegasystems have built an awesome low-code platform that uses AI-powered decisioning and workflow automation to solve some of their clients' challenges. We're going to be uncovering some really interesting details and challenges surrounding what they've built, and Andre's going to guide us through some of that and talk to us about some really interesting scalable and data challenges. Andre, thanks for joining us. How are you?
Good, very good. Thank you for having me here.
Absolute pleasure. Absolute pleasure. We always do this on the Engineers Podcast, Andre. It would be a really good idea to get an overview into you, your role in the business, and also what Pegasystems do for some of our listeners who don't know you or don't know the business.
Maybe let's start with myself. And as I said, thank you for having me here. It's really nice opportunity and in a way a challenge for myself. And I hope that at least one sentence that I'm going to say today going to resonate with the audience, and I'm going to help them with whatever they are looking for when listening to this podcast. My personal story, in a way, very boring. Because since I remember myself, I've been in love with technology and software and building software. And that's what I do pretty much for my entire life. And that is my hobby, that is my work, which is pretty cool. And I work as a software engineer. I started as a software engineer working in multiple companies. And by the way, I'm originally from Minsk, Belarus, but pretty early in my career, I moved to Amsterdam, to the Netherlands, where I also worked as a software engineer. But something that probably describes me and something that I took from my university class, my professor used to say that an engineer has to be lazy, and a good engineer has to be enormously lazy. That I kind of took this to the heart, and that's my motto through life, which annoys my wife sometimes, of course. But in my day-to-day work, at some point, I realized that I actually don't need to code. I don't need to write software myself, and I can have other people doing this for me. I can work with other people who will do this, and that's how my engineering manager, engineering leadership role started.
Okay.
And what I actually do, I like to describe this that I do whatever needs to be done. And that means that I have sort of a multiple personality disorder. On one hand, I'm managing an engineering team here in Amsterdam, in Pega, Amsterdam. And I work with teams, I help them to build software. I work with other engineering managers and help them to grow their leadership roles. On the other hand, I work with customers, helping them to solve their problems and resolve their issues. And also sometimes when I have time, I try to be hands-on and look at the architecture, maybe even sometimes implementing some tools. In the end, I'm just doing a lot of engineering work and a lot of fun.
I think something that you touched on that really resonates with the podcast as well. If you say one line that someone can take away from this podcast, that's what we're all about building. So I think this is the first time that we'll ever speak about a low-code platform, what a low-code platform is, and some of its utilities. We'll uncover that, but I think you hit the nail on the head about what Engineers is all about. Before we talk about low-code platforms, which is, a hot topic for today, can you talk to us about who Pegasystems are and what problems they solve?
Yeah, of course. So, a general sentence that would describe Pega is it is a scalable low-code platform for AI-powered decisioning and workflow automation, which is a very packed and compressed sentence that is probably doesn't tell you anything. And maybe in the next 5 or 10 minutes, I will try to unzip it so you can understand it a bit better. One thing I really wanted also to mention that the Pega is not new to the market. Pega, we actually celebrated 40 years last week. 40 years on the market,
Wow.
which is pretty cool. And we are located in many different countries. And I represent here the Pega Amsterdam, which is pretty small office to be honest. Let me go back to this scalable low-code platform for decisioning and workflow. And there are three key words here: platform, decisioning, and workflow automation. I will probably start with the platform. One thing that it's kind of important to say here that we are building a platform or a framework, or in other words, integrated development environment for business. We're
Mhm.
not oriented to end consumers. We are oriented to business. We're business to business platform. In other
Mhm.
words, we give them tools. We give businesses tools so that they can build applications, whatever applications for their customers. And sometimes I describe this also as a Lego constructor. So we have a platform with a lot of building blocks that you can stack together and get any application that you want. It can be as big as a sales platform or as small as a to-do list. Really depends on what you want to build. We just give you the platform. That's the platform part. The decisioning and workflow automation. I think it's probably better to give an example here as well. Something that resonates really well with me, and it's a situation that happened to me last year, and I'm pretty sure that it happened to many people who are listening to this podcast as well. Last year, I've been traveling for business, and on the way back, I got stuck in an airport. Basically, the airplane got broken. And the worst part is that we were in the airplane sitting for 3 hours waiting until the issue got resolved. But in the end, it just says, no, sorry, the airplane is broken. We're not going to fly. And that's, well, as a as a passenger, it's really terrible situation to be in. But as a business, as the airline, it is a huge problem
Yeah.
because suddenly you have 300 passengers. You have 300 people who are angry, tired, they unhappy, and you need to deal with them. Now, what do you do? Maybe 10 years ago, 15 years ago, the standard thing to do would be to send all of them to an agent, and then agent will handle these passengers one by one, writing them new tickets, sending them to hotel, and so on. But that
Yeah.
means that you have 300 people waiting in a queue for hours
Yeah.
before they get handled. That's not really nice. And that's the where the decisioning and workflow automation comes into the picture. What we try to do here is to start engaging with customers and passengers in this case before they get to hate. So as I walk
Mhm.
out from the plane, I get an email that says, hey, I'm sorry your plane got canceled, but we already booked you into a hotel and you also booked you a separate flight tomorrow.
Yeah.
Don't worry, just go relax. And here's also a voucher for dinner, blah, blah, blah.
Yeah.
Okay. And well, I'm telling you this, but probably it's a in the present world, it's a very natural thing to happen. Everybody expects it. If you look under the hood and you really think of this, what it takes for a company to build this, it is actually pretty complex because,
Yeah.
well, you have 300 people. The first question is like, what is the best thing to do for them? What
Yeah.
is good for me may not be good for you. I'm okay to go to a hotel and sleep over. You
Mhm.
are not. You are having your connection flight or you have some other urgent needs. So deciding what to do for a person is not a trivial task. And well, usually we call this that's a decisioning process. And once you decide something, okay, go to the hotel, rebook the flight, I don't know, cancel the flight, then you need to go through an automation that will actually do this. Because to book the hotel, you need to go into the reservation system. To book a separate flight, you need to go to the reservation system as well. And there are multiple steps that needs to happen in order the whole transaction to be completed. And somebody needs to orchestrate it. That's in essence, what we try to help companies to build. It would be untrue to say that other companies don't do this, or
Yeah.
we are the only ones who do it. That's not true. And in fact, I don't even know whether the my travel was handled by Pega or by some other company. I don't know that. What we strive to do is to make these type of use cases, these type of implementations accessible for business. So they
Okay.
don't need to involve IT departments and developers, engineers to build it. It's actually a business who can implement this type of transactions.
Interesting. Okay.
Yeah.
My question to you is going to
Mhm.
be, was this Pega that actually built this system? You
Mhm.
don't know that answer. There are some things that I'd love to
Mhm.
explore in regards to real-time decisioning,
Yeah.
how that actually happens and who that's being done by. We'll come on to that in the next
Mhm.
couple of moments. Are you able to give us some concrete examples of where some of your clients have implemented Pega into their
Mhm.
business and what value that they've actually seen?
Oh yeah, of course, yes. So, well, the example I just gave you is potentially real Pega implementation.
Fine.
I don't know whether this particular case was Pega or not, but
Yeah.
we do work with airlines. We do work with airports to handle this type of situation. Most of our customers are in banks or insurance companies or telecommunication companies where they need to automate all sort of processes. And you can think of this simple as, okay, address change. That's a
Yeah.
process. Or applying for a mortgage or handling insurance claims.
Yeah.
Okay. So that's what our primary business is. We help these big enterprises, and those are really big enterprises. You can think of top 500, top 1,000 companies in the world, and we are helping them to automate their processes and add uh, AI capabilities
Yeah.
in the mix.
Touching on the real-time decisioning,
Mm-hmm.
my head's spinning with how this actually happens,
Yep.
who makes the decisions, the scale and the volume, the speed of that
Mm-hmm.
decision. There's a couple of things there, but it would be great to understand what actually happens under the hood
Yep.
and the challenges when building that and why it's so seamless for customers.
Maybe we can go to a slightly simpler example, and which is very real, and a lot of customers use us for this. We call this, well, we like to call this as a one-to-one customer engagement. The example I just gave you was an airplane. This is one-to-one engaging with your customer.
Yeah,
But this is also a very obvious example. We have a problem. We need to engage.
yeah,
But there are a lot of situations when it's not that obvious, and you want to keep this engagement continuous.
yeah.
So one very simple but very popular use case that we have is sort of, I would call it a marketing use case.
Okay.
A simple example: you log into your um, bank account, and then you see all sorts of uh, banners that try to sell you something, right?
Yeah,
And the reason you see this is because business, or bank in this case, sees this as an opportunity to engage with you. You log into your website and we can start a conversation.
yeah,
And depending on how well you do this, you can increase your revenue click-through rates. And that's what we help banks and telecommunication companies and others to do. It's literally you log into your bank website, to your account, and then a REST call goes into Pega. And Pega, the REST call, will tell you what banners do you need to display, and sometimes even where. If you want to see the big one or somewhere on the side,
smart.
what, and you might have even multiple banners to represent the same thing, but depending on who you are and your preferences, we may show you different banners. You know? But as this REST call happens, It may sound okay. Well, many companies do this again, right?
Yeah.
There's nothing very cool about this. But if you dig into the technical details here, well, first of all, the REST call needs to happen. You're
Yeah.
not going to wait until the banner will spin for seconds here. So it needs to happen in 100, 200 milliseconds max, and that's the whole run. But as we execute this call, we also need to consider all sorts of business rules that are applicable
Yeah.
for this customer. Yeah, and if you ever worked in a bank or complex enterprise, you know how many rules they have. Actually, engineers hate them because they have hundreds and sometimes even thousands of very specific rules that apply to regulations and
Of course they do.
customer preferences. There's so many rules. So we need to evaluate all these rules before displaying something to this person.
Yeah.
Yeah. We also need to know what is the current holding of this person. Maybe you already have a credit card. So why would we try to show it again and again?
Yeah.
Or yeah, maybe insurance. You don't want to show certain insurances if the person doesn't have a house. Next to these business rules, we also want to apply some machine learning and AI. And in particular, we want to evaluate the probability of a person liking or needing the thing that we're going to display. And all of this needs to happen in 100 to 100 milliseconds. That's
Yeah.
not easy.
No. And,
So, yeah.
I was going to say, especially you touch on the rules part.
Mm-hmm.
We've spoken about rules engines on the podcast before, and building those, how complex they can be and how they're constructed. So especially if you're working with banking or financial
Mm-hmm.
clients, going through rules engines, at the speed that you need that to happen, I can imagine that's really tough.
Yeah.
And then interfacing that.
Also, as it is, rules are usually for the business people, and
Yeah.
they are not engineers, so they don't really care about performance characteristics. They don't know
Yeah.
whether comparing a list of items this way or that way has any performance implication. They don't know about it. They just want to express their business rules. And I'll go back to this at some point because that's one of the interesting learnings that we had in the past. But I also wanted to mention that if you look at this requirement that I just told, right, the REST call and AI needs to happen, business
Yeah.
rules need to happen in a short period of time for one big bank. I don't know, you name it, but a bank with millions of customers who log in
Mhm.
into their accounts all the time, or maybe they're using their mobile applications to do payments, and those are sometimes thousands of calls per second for a single bank.
Yeah.
Now we as Pega have more than 1,000 clients of this sort,
Yeah.
and that means that you have one huge bank, another huge bank, and a third and fourth, and so on, and they all making these decisions in parallel,
Yeah.
which at some point means really tens of thousands, sometimes hundreds of thousands decisions that they need to make every second.
Wow.
And that's yet another dimension of a challenge that we have to solve this. Especially, it became a problem recently because well, in the old days, we would sell our software to the on-premise customers, right? And
Yeah.
then the scalability is not really our issue anymore.
Yeah.
They can install whatever the software they have or hardware.
Yeah.
But in the last 5 years, we migrated the majority of our clients to what they call Pega Cloud.
Yeah.
Yeah, and that's a cloud offering.
Yeah.
And that means that, well, now we are responsible for scaling. We are responsible for the service level agreement. And obviously, we use all sort of technologies behind the scenes to achieve this. We use Kafka, we use NoSQL databases, we use data processing pipelines. We recently started to use Kubernetes that helps us to partition customers, isolate them, and do all sorts of smart routing strategies to ensure that we can deliver our SLAs. Okay.
There are a couple of things I want to ask
Mhm.
you. I am aware we've probably jumped ahead a little bit.
Yeah.
Would we be able to explain to people what a low code platform
Oh yeah.
actually is? Because there might be
Mhm.
people listening that aren't really sure what we mean by that phrase. It's relatively new to the market, and I attach it to certain
Mhm.
products, but it would be good to understand what you think a low code platform is.
Mhm. Yeah. Yeah. And I maybe can give you two examples here.
Cool.
See, a very primitive one. Yeah, just think of you needing to build a website for this podcast.
That's my one as well. That's
So
my example that I use for people.
okay, yes. So you need to be out of your mind to go and start coding HTML, JavaScript,
Yeah.
and whatever other programming language, right? You don't do this today. You take something like a WordPress or any other sort of a low-code platform that will help you to build your website without knowing
Yeah.
anything about software. You just go, you choose a template, you apply certain configurations, you build the content, you focus on your content in the end.
Yeah.
And that's the you can think of this as the low code for building websites or yeah, web shops.
Yeah.
So the Pega as a low code platform is very similar in nature, but for enterprises, for big banks. You don't need to learn Java. You don't need to learn Docker, Kubernetes, or Kafka in order to build your sales platform or call center platform or
Yeah.
mortgage application portal.
Yeah.
Okay, so that's what Pega is. You literally don't need to know software engineering on all these technologies in order to
Yeah.
build pretty complex platforms. Yeah.
Yeah. That's exactly my example. People come to me and ask me about low code platforms.
Mhm.
I always use the Shopify
Yep.
website expression to try and explain and articulate that you can actually construct it without actually knowing any software engineering or having any technical background. It it would be good to understand from building this real-time decisioning platform, really what's been A, the biggest challenge, B, the biggest learning.
It is interesting, but the biggest challenge and the biggest learning are kind of correlated.
Yep.
So the biggest challenge is how to do this fast.
Okay.
Yeah, but that's yeah, in a very simple term. But you could also ask why is it a challenge to make it fast? And what we learned in the past is we approached our platform in the wrong way. So we just talked about the low code platform, right? But typically, when people think about the low code platform, they really think of, okay, I will be programming, but I will be programming in a visual way. I will draw shapes and arrows and block diagrams, and that will be my low code.
Yeah.
Okay, and that's how we started, by the way. Now, I really believe that this is not what low code platform is, and that's our big mistake that we made here. I'll explain why.
Yeah.
So you can think of this. Okay, we have I mentioned those technologies like Kafka and databases, data processing pipelines. So obviously we have all of this in the background. But then as a software engineer, you tend to expose those technologies in a much simpler way to customers. For instance, we would start and say, look, you can create a queue. But we don't tell you where this queue is, but it's just a high level concept of a queue.
Yeah.
And by the way, you can also apply some processing on this queue. And you express this processing as a block diagram.
Yeah.
Yeah. So now our customers can go and create queues. They can attach some state and block processing on top of this queue. Then we also said, look, you can also have this visual decision-making process interface that, again, like a flowchart diagram, but now tailored for decisioning. And then you can stitch all these things together. You don't need to write code, and this thing gonna work.
Yeah.
But once we release this to customers, what we realize that they start to use it in a way that we didn't expect. So, for example, they would go and create 200 queues.
Yeah.
And start moving things from one queue to another, then call decisioning process, call some databases for some data in a way that was pretty much indistinguishable from the normal software. But
Got it.
instead of writing code, you just do this in a visual way. So I call this an imperative paradigm, right? So you really describe how the system should solve your problem.
Yeah.
Move record to this queue, then pick up, then apply decisioning, then move to another queue, and so on and so on. But in essence, that's just a programming language. And once you give people who are not engineers to the programming language, they will
Yeah.
create a mess.
Yeah.
They will create a mess that we need to run, and we need to guarantee that it executes in a,
Of course.
in a certain time. But how do you do this? If I give you a Java-like visual language, and then you are free to write whatever you want, I cannot
Yeah.
guarantee to execute this in 200 milliseconds.
Yeah, exactly. That that would be a challenge, not really understanding like the concepts of software engineering, but
Mhm.
why would you think to apply them um, when it's a low-code platform and it's easy to construct things
Mhm.
and build a workflow a certain way? You're not really understanding of what's happening under the hood or some of the changes that you're making. There's there's quite an interesting thing that sprung to my mind around challenges with data. And I know that's something that you're particularly keen to talk about, and one specific example being controlling contracts using Spark, Databricks, and MapReduce. But I think that the wider data challenge itself would be really useful, I feel, for people to
Mhm.
learn, listen, and understand. So, can you share how that actually happens with Pega
Yeah.
and some of your clients?
Yeah. Yeah. So I actually won't be talking about Spark and Databricks here. Um, uh, but the concept that I want to talk about, it generally applies to many aspects of software engineering, and actually beyond software engineering, also in the daily life.
Yeah,
So what I just described you, this challenge of someone imperatively, like procedurally describing how to solve a problem, we realize that this is really not a good way of doing that.
yeah,
So instead, what we started to do, we started to ask our customers, what is actually you want to achieve in the end? Don't tell the platform how to get there. Tell the platform what do you want in the end. In sort of, you just declare the outcome. You declare what you want to get. I want to um, increase the happiness factor of my customer. I want to sell more products. I want to increase my customer base, so on and so on. Right. So instead of telling how to achieve this, tell the system what do you want. And I call this nowadays. I think it's fair to call this as prompt engineering. Now, with ChatGPT is an amazing example of this declarative prompt engineering.
yeah,
Instead of uh, they show that instead of you take all these tools and machine learning libraries and then solve your problem, you actually reverse the process and you go and describe what you want in the end.
Yeah.
The system will find the best way to do this. So in our particular case, we would say that instead of describing the decisioning process, we would
Mm.
ask you what are the business rules that apply to your domain. Describe your business rule, and describe the outcome that you want to achieve. I want to get more uh, customers or
Yeah.
more revenue or whatever the metrics you are trying to optimize to. And then this becomes a sort of a desired state. That's the declaration of a user of the desired state of the universe.
Yeah.
This is what I want, and these are the constraints that I have. And then behind the scenes, the system will start the well, kind of generate the implementation of this process, how to get to this desired state. We'll create Kafka queues, we'll create all sort of data pipelines that move data around.
Mm.
That the key here is that it's no longer the low code developer who creates this automation. It is us who can today create one Kafka queue, tomorrow create 5 Kafka queues. Maybe then we find a new best way to execute decisions. I would just substitute something behind the scenes, but the contract, the desired outcome stays the same.
Moving to prompt engineering, I'm really visualizing it as you're explaining it. It actually reduces some of the problems where you've probably had in previous times with people using the platform with no software engineering understanding have made a bit of a mess of the platform because you've probably created such a saturated system with, I'm sure, many queues that in the end that don't really do a great deal. But actually getting to that prompt engineering phase and asking the user, where are you looking to be? That can actually make the decisions for them instead of taking them on that journey.
Yeah, sort of, yes.
Okay.
Yeah. Another very simple example that we struggle a lot. We have this. Well, I described you the decisioning process that we call inbound. You are calling your website, just calling the rest.
Yeah.
Sometimes you want to do the opposite. As simple, you want to send emails or whatever other ways to reach out to a customer overnight.
Yeah.
Yeah, you have Black Friday. You want to go through your entire customer base and offer them something. What we used to do in this case, we have this concept of a batch pipeline that you can run. And we would ask customers literally to tell how many threads do you want this pipeline to run? What are the failover policies do you want to apply? You know, especially if you work with Spark or you work with
Yeah.
Flink or any other pipeline tool, you know this. You configure nodes and you configure priorities and threads and memory and a lot of technical parameters. So what we used to do, we would expose those parameters to a low-code developer.
Okay.
And oh, what did I do? And I say, oh, you asking me about number of threads. The only thing I know that I need to complete my campaign within 1 hour. So let me put 100.
Yeah.
So, well, 100 or 200. Can I put 1,000? Yeah, maybe. And that's what they would do. And the fact that you put 100 doesn't mean that you're going to complete it in 1 hour. And in
Yeah.
fact, the end user don't have enough information to reason what would be the right value to put. So instead of this, we would start turning it into, upside down. How fast do you want this to complete? What is your SLA for this
Yeah.
campaign to go out?
Got you.
And from this point, we can, okay, now I don't know, whatever we run behind the scenes, maybe we go with threads, maybe we go one thread or one machine, 20 machines, really depends on
Got
our
you.
underlying implementation. It is coming to the, how do you establish the right contract with your
Yeah.
user?
I think that's a really interesting place that you've got to, and I'm not sure if ChatGPT accelerated that process, but I'm going to start using prompt engineering. But it seems as if the platform has evolved with how users now know how they can actually use a platform,
Mm-hmm.
which I think is a really interesting concept. What's to come over the course of this year, or let's say 12 months? What's to
Mm-hmm.
come in some of your engineering departments?
Well, well, you can probably imagine that the whole chat GPT and the language models, they are
Yeah,
disrupting the whole everyone.
yeah, exactly.
And especially in the, well, not especially, but in low code uh, domain, it is a hot topic
Yeah,
because, well, everyone sees an opportunity. Everybody feels that this is a big thing, but nobody really knows yet how to apply this exactly,
yeah,
right? So you can also go back a few years ago when this blockchain was a big thing, right?
yeah,
Everybody was trying to do a blockchain because they'll feel, okay, this is something, we need to use it. So same happening with GPT and other
true.
language models. And in fact, we already have a number of features that are coming out probably in June that will leverage the prompt engineering. You would be able to do things like, hey, I need a process for request a credit card,
Got you.
and the system will just generate you automatically this process because ChatGPT is very good at explaining you what is the typical and average process of credit card application is. For decisioning, we are experimenting with a very interesting feature that would generate you text of email messages or banners. We actually conducted a research that says that depending on you may get very different reactions depending on how you approach a person in terms of the message
Yeah,
that you write. Because some
spot on.
people, so these type of things we're going to be doing for sure.
Will 1,000,000% be keeping an eye on what you're building, some of the feature releases, in June, obviously. Really good luck for those. You're directing engineering. You've probably got visibility on what you're looking to hire into the Netherlands office. We've got,
Mhm.
as a podcast, a really big presence in the Netherlands. So if people are listening and they're genuinely very interested in what you're doing and what you're building, talk to us about some of your growth over the course of this year and beyond, and what you're looking to bring into the teams, if any.
Really depends on when you are listening, because it can be you listening in
True. With start of
2025.
May.
Yeah. um, so I would not really focus just on Netherlands because our presence is pretty big in US, in India, in Poland, and we are hiring across those locations. Um, and typically, we are looking for. I usually describe this as just a strong software engineer. We don't care that much about frameworks or all these uh, cool and trendy things like Spring Framework or knowing the Terraform.
Yeah.
We're really looking for the core engineering skills typically. And we are hiring in data science departments, we are hiring core engineering, we are hiring in cloud, in security. So we actually have around 3,000 engineers in the company. So yes, we
Wow.
do have a lot of um, opening.
Wow.
Yeah.
That's pretty phenomenal. And I think learning from today more about the business, a 40-year-old business that has evolved to times where you service 1,000 clients and you're now involved in, I love the word prompt engineering. I'm going to start using it definitely, but you're there at that point. The business has to be a fantastic business with really solid foundations to really
Oh, yeah.
continue to evolve and support, many 1,000 clients. So it's really interesting to see what you've done. I think it will have the same appeal for people listening. And there's obviously an array of opportunities across cloud, security, software engineering. So if you are listening, the careers site, as always, is below in the description. Check out the guys and girls at Pega. Andre's based in Netherlands, but as you know, they're hiring multi-locationally. So feel free to reach out to Andre. And I want to say a big thanks, Andre, for coming to join us, giving us lots of insight into Pega, the business, how you service some of your clients, what a low-code platform is, but also the challenges around building, a real-time decisioning platform and what's to come has been awesome with so much context. So thank you.
Yeah. Thank you very much for having me here.
It's an absolute pleasure. And as usual, for everyone listening, it's really important that people do like, share, subscribe to the platform so that we can actually allow and continue to propel us forward so that people can share their stories. And again, a massive thanks, and we'll see you soon for another episode.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no underscore. We've also got a website which is enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.